Hi guys. I think we've got the graveyard slot here this afternoon, but anyway, we'll forge ahead. Our brief here is sorry, the format that's a little bit different. Our brief here is BIM, bringing intelligence to design. I suppose from our perspective, really, we're a design-led organisation, so we're always trying to add value for clients in terms of defining the overall design process correctly and spending time at the front end of any project. Effectively measure twice, cut once, spend 2 hours of any 6 sharpening your axe before you cut down a tree and all of that. The industry we're primarily involved in actually is the mobile telecoms, as in wireless and fixed line space. And we're bringing BIM to bear in that in a variety of different ways at the moment. The general understanding of BIM in that area still applies, in that it's a shared knowledge resource effectively, and it's a collaboration tool for multiple stakeholders to be able to work on a given problem and come up with a more holistic solution that gives the best benefit to a client. Again, the main benefits that we're looking at is that it creates efficiencies, it saves time, reduces waste. We're bringing intelligence into the planning and design phase, and we're delivering a reliable basis for informed asset lifecycle management. The last one here in particular actually is quite an important point in the area that we actually work. And the reason for that is that a lot of what we do involves multiple visits across either a year or multiple years to a particular site location. And that's as a result of tech interventions being required on a particular site, or technology upgrades, for instance, and swap-out programs being required on sites. Every time there is something like that required, a survey visit is necessary. And you could tie this in as well in relation to fault resolution. And a lot of that is because the information that's available for these sites is not really maintained essentially by the owners of these assets and this infrastructure. So there's quite a large benefit that BIM modelling can bring to bear in this space as well as other spaces. And some of the work that we've been doing has been involved in understanding, I suppose, how we can define the current site setup in a degree of accuracy that will allow us to construct a BIM model, but to do it at a cost, let's say, that's going to be appetizing for our clients. And again, we also need to be able to do it to a degree of detail that'll provide value both to ourselves and allow us to develop a technical solution, and allow our clients to have further intervention on the sites in years to come. Okay, so in terms of what we're looking at here, for instance, this is a mobile telecoms tower. This is approximately a 60 to 70 meter structure, I think, this particular one. So we'd actually model this in a Revit and Robot package, and integrate it into a Navisworks program to do an interrogation of the overall space. We can as part of the overall BIM, we can also add certain attributes then to various components, so we can understand what their servicing cycles, for instance, are, what their power budget, power consumptions are, and that'll all relate into the HVAC and power budgeting for a site. Quite an important part here is the space requirements on pieces of infrastructure as well, or within specific rack areas, because a lot of our clients actually rent space on these, and that's quite a valuable revenue stream for them to be able to derive a revenue stream, just much like a landlord in a building would rent out rooms or rent out an entire floor area in a building. A lot of our clients would actually rent out particular space. So understanding the apertures, let's say, that they have available to rent at any time, and understanding as well that their clients are operating within the means of their license agreements is quite important. This is something that we've looked at in terms of analysing the controlling, I suppose, the data and being able to filter back information from the field. A lot of what we do also entails conducting site surveys and progressing site designs into build, and also performing quality audits of build activities at the back end of a rollout program. So being able to, like, what we've found is that the translation of any issues on site back into the design offices, how accurate that is and how streamlined that information flow is, makes it increases, I suppose, it can reduce a lot of stress from both our point of view and our client's point of view if that's done in a relatively neat way. And being able to operate and for everyone to actually be able to see the working model or the collaboration space and be able to mark that up, we found to be quite beneficial. Something we've looked at here, and in some ways it's quite a simplistic application of BIM, but it's quite a powerful one nonetheless. It's a little bit different maybe to what the general construction industry would understand BIM to be, in that they understand it to very much be a 3D model or a 4 or 5D model. This is very much a two-dimensional model, but with particular BIM attributes that we've actually developed. And this is specifically in relation to the rollout of fiber networks. So in relation to this, what we've tried to do here is essentially take a design-led approach to developing a design solution for fiber rollout. And what we've had to do is take a lot of existing GIS information and define various project rules and guidelines. So you're looking at various civil engineering, technical, health and safety constraints, and we're looking to integrate them in one model space and produce an optimized design, because again, I suppose the scale of the networks that we're looking at here are hundreds and thousands of kilometres in length. They're nationwide networks in Ireland and the UK effectively. So once we're able to do that, like doing that and doing it quickly allows you to do it quite cost effectively, and obviously producing the outputs that we produce on the back of this then need to be quite detailed to allow clients to understand what's going to be required to actually develop for them to roll out their networks, as in how many lengths of a particular type of fibre cable, how many pops, splitters, etc. that they're actually going to require, right down to the lengths of ducts, manholes, you name it. So part of what we're trying to do is we're doing our overall process. We put a lot of effort into the front end design before we actually need to go and do a field validation survey. So we're able to create an optimized design and conduct a virtual walkthrough in a Google Earth environment to understand clashes, constraints, etc. This has actually streamlined the overall design process from our point of view. We've actually reduced the design time in comparison to how we were initially conducting this by about 80% actually. So there was a significant saving in the time it took to achieve a design outcome. The other big benefit we found in this actually is the saving that can be realized in the build phase. Because the design is now relatively optimized to a certain degree, we've been able to conduct multiple design iterations, and because we're working with an intelligent model as well, once we perform updates on the model based on either field validated data or field validated constraints, as in we discover a duct is blocked, or there's an issue with gas or water services, for instance, where we were looking to propose underground trenching, we can update our model space quite easily, and that'll automatically link back into our bill of materials, which is quite useful for our client build QSs to be able to understand how the cost impacts of choosing one particular routing over another. So just to summarize briefly then, from what we've seen is the benefits of BIM in our overall workspace is the program cost savings that can be derived for both organizations that take BIM up and also their clients, the technical and quality confidence that you can control both internally in your organization, and also that you can ensure that any of the outputs that you're delivering are are relatively consistent. Again, people are working in the same model space, they're working within the same rules and constraints. So you're going to limit the amount of interpretation, I suppose, that's possible when you're working within large design teams, which it's a pretty good thing when we're not dealing with something that's necessarily an aesthetic design, you know. The time to market, obviously, as well, is a pretty critical thing for our clients, in that they're always looking to roll out their next generation networks, etc. So by being able to compress the design process while also still maintaining the quality levels and actually improving the quality levels and improving the quality of the bill of material information that's available, that's quite a critical component. Also, as part of these, you can make these models a little bit more sophisticated as well, in that you can layer in population statistics. So, for instance, you can understand what the likely uptake, again, just looking at a particular fiber network or an overall wireless network, you can understand what the likely uptake is going to be in terms of the customers that are in a particular area based on their age profile or families or dwelling sizes, etc. So that's a pretty brief, I suppose, introduction to it, and if anybody has any questions, feel free to ask. Everyone is shy, that's okay. I'm sure you'll have one.
Well, thanks very much, Niall. With this, we will close this session and go for a coffee break. And new session starts at 2 o'clock. Thanks very much.